Goodness, where to start? Let's go for it. What's the first example I'm talking about? There are two topics in this tutorial, which are really the same topic. How to, as a modern biologist, handle the onslaught of data that we are experiencing in the lab on a pretty much daily basis. I mean, when I started maybe 20 years ago, the first time I touched anything related to image processing, if you had a terabyte of data, it was almost impossible to save. Everybody had a few, maybe a gigabyte, 2 gigabytes was a huge amount. And so the issue of big data was not quite there. And by big data here, I mean in quantity and in number of files you need to manage. It's not the same to have 10 files, 100 files, even 1,000 files. That then there's a qualitative change when you suddenly have 10,000, 100,000, several billion files, as some of the recent projects I've been working on had. That goes down to even having to adjust file systems because there's not enough IO handles in the file system tables and whatnot. Let's not go into that detail. So we're going to work here on a happy in-between in which your data is not so big that you need the resources of an entire institute to work on them, but it's not so small that you cannot handle it. It's not so small that you cannot handle it trivially. You need some kind of strategy. So like I was saying, this is all about the in-between. And this in-between means you may have commercial software that says, here's your collection of files, and you can manage it, and it offers you a little web page, so you can annotate it and go through it and whatnot. I have strong opinions about most of this software. The reason is I've used a lot of them, and they always end up falling short of your expectations because your particular project is unique. You're going to have different conventions, different numbers of files, different ways of storing the files across many systems or whatnot. So what I want to teach you in this tutorial is to be fearless about developing your own way of handling very large sets of files and browsing and analyzing them. This is less daunting than it sounds because there are many libraries for doing so. These libraries, of course, you need to discover them, where they are, how to use them. So this is what we're going to do here. And so some of the basics I need to touch on will sound very, as I said, very basic to many of you, but I hope you will still get something out of it. So what are we going to do first? I'm going to bring up Fiji, and for that, I'm going to bring up my entire desktop. So I'm going to first put a few things away, because there are too many things right here. And where is this? Right there. OK, as I see Fiji, I will probably not see you, which is a problem. I'm going to try to put the chat window somewhere where I can also see it. Let's see if we can manage. So let's gonna share my entire screen. And I see that you can see it now. So there we are. Here's a chat window, which unfortunately I don't have two monitors. I'm going to have to keep it somewhere available in there. There we are. This we're going to need later. What have I open here? I just went to File, New, and Script in Fiji. This tutorial, by the way, I did mention over email, though, is based entirely on Fiji, this open source software for image processing. What I've done here is I went to Language and Python. Python is the language I'm going to use here. This, as I push Control-Shift+, I can change the font, or Control-. What I'm going to show you first is how to deal with graphical interfaces. Because what we need to do now is, suppose we have a large collection of files. This collection is, like I said, maybe in the 100,000 of files. Uh-oh, I accidentally gave host to somebody. Is that right? Let me check that out. What I was doing is I was trying to show you a Fiji screen. Let me see. We were trying to say how to deal with graphical interfaces, how to build them. And for that, you need to know a couple of concepts. One of these concepts is the listener pattern in programming. Oh, wait, Francisco cannot hear. Go on. So what do I mean by the listener pattern? For instance, most applications are built in such a way that as they execute whatever it is that they are doing, say, for instance, image A is opening a file, it gives you the ability to insert some of your program into that, so that when it opens the file, it notifies your program that a file has been opened. This is very convenient because it means you can capture what's going on in the program around you. In the same way, you can do that for keystrokes, for mouse events, and for focus events, and many others. So I'm going to start by illustrating with these very simple examples what I'm talking about here. So let's create a program that can do that. So first of all, I'm going to need to create a listener. And so for that, I'm going to make a class, and I'm going to call it, this is the file open listener. You can all see my screen, I assume. Yes, thanks. Right, is the font big enough? Because my screen is pretty big. Is that better?
It was good before. That's
okay.
Maybe too
that's
big.
Fine. Maybe too big. That's fine. All right, so let's do this. And now we want that. Image listener from the IJ. There we go. So a class in Python, for those who are not familiar with, is simply the class keyword, the name you want to give it, and then whether it implements any interfaces or abstract classes. This image listener is the interface that ImageJ defines for us. And now it has a bunch of methods. I've forgotten what these methods are. And so what I'm going to do is select image listener, or select it here. Go to tools, source or Javadoc for class or package. And this now brings this little window here. And the image listener is this middle one. It has a Javadoc. I'm going to click on it. And this now is open in the web browser. File not found. You're kidding me. How is that file not found? OK. Why don't we go to the ImageJ website? And ImageJ documentation, there's going to be, why am I not seeing? The developer resources. Here it is. Developer resources, the API documentation. That's where I wanted to go. API means application programmer interface and describes all the classes and methods and whatnot, functions basically that you find in this library. So somewhere down here, there's going to be an image listener class. There it is. It is in cursive, italics, which indicates that it's an interface, public interface image listener. And then it has 3 methods. And since I'm lazy about it, I'm going to just copy them. Go here, paste them. And now what I'm going to do is define them. So what I want to do is I want to add this self, which means in Python that this is the internal reference to the class instance. So once we create that object, this is the way to refer to whatever properties of that object. And if you add a pass to the method, it means I don't care about whatever this method does. This means do nothing. So the next one is this one, which again is a self. And the IMP here is meaning the argument, which is the image plus. It's the object internally that ImageJ gives us, which is the image that was just opened. So I wish there was a better way to do this, but unfortunately, I have not finished what I wanted to do, which is to create a full autocomplete in this script editor. What we have now is a class that does nothing. So I'm going to replace this middle method, it has 3 methods, with print. Just print the image plus. So here I create my listener, which is going to be a file open listener with the 2 parentheses where I'm saying is invoke a new instance of that. And now what I need to do is image plus, and I can just do this and get it to self import. And now I want to see a method called add image listener. I'm pushing Control space to autocomplete. And I'm going to add here our listener. And so as I run this program, now here on the right, the first time Jython runs, it takes some time. Later, it's just instantaneous. Now it's basically has run, and nothing has happened, which is good, because now we're going to open an image. We can take, say, a sample image. And as the image open, you can see here that it printed, actually, what the image is, this gold, lead, antimonium, whatever, 40, some metal example image. So this is an example, a very simple example of a listener pattern. We created this listener, we added it to a library that knows how to deal with it, and that is designed so that it will do something that we expect, because that's what an interface is. It's a contract that my program and the other program basically establish with each other, so that when a file is open, this method of my program will be called because I've given my listener to that program. And now I need to rescue, where is this, so I can see messages. Right. Is there anything else I should pay attention to? Just please unmute yourself and speak if you need to. Everything's fine? All right. Then, this is a very simple one. Why am I showing you this? Because now you have the ability basically to do something when you open an image. This will come in handy later, as we will use it later. What else can we do to this image? Now you could grab this window, and to this window, you could add a mouse listener, so that when you move the mouse, it tells you where the mouse is. There's endless possibilities like that, because every element of this window has listener interfaces that you can add. And I want you to look at this window again in a way that you may never have looked at it before. And so this window consists of at least 3 parts. There's the frame outside, which is that's what in Java is called a frame, is the actual window itself, is a container. And then inside, we see 2 bits. We see the image at the bottom. And then here we see a label that contains a bunch of text that informs us on the dimension of the image, the bit depth, and the size of the image file. Actually, the size of the data as is expanded here in RAM. You can build an interface like this. And I will show you in a moment how to do that. So before I go into the bigger examples, I'm going to do these simpler ones just to illustrate what we're talking about. So let's do a new one. And now what are we going to do? Let's create a window. So like I said, this is called a frame. I'm going to use the Java Swing library to do this. And so I'm going to import here. I don't know if you can read it, but it says from Java Swing import frame. I say, yes, that one. I know that it has an argument. And this argument is the title. So I'm going to say this is our first window. And then to this frame, we want to add a panel that can contain other things. Yes, go ahead.
Good question. How do you kill the listener that you have running?
That's right. So basically, this listener will be there forever. That's a good point. If you want to remove it, now we need to tell ImageJ to do so. And so in this case, I can write a new program that basically says, okay, what are the listeners? And that's going to be an image plus, I think is the remove image listener. Unfortunately, I don't know that ImageJ enables us to retrieve all the listeners that it has. And therefore, okay, let's spend a minute doing this because I see that it's something we should have clear. Listeners can be added and can be removed before I go into frames and UIs. So here we made a mistake of basically not having a pointer to our listener. By a pointer, I mean we lost this variable. Once the plugin, the script was run, since we didn't push persistent, I have lost actually everything that was in there. The only copy, the only instance is stored internally in ImageJ in its list of listeners. How can we recover that? So unfortunately, Image Plus does not offer us any such method like that. There's add image listener, and then I believe there's remove image listener somewhere. Yeah, there's remove, but there's no get listeners. So how can we do this? Well, now is where we can hack a bit. Everything exists in there. It's a matter of knowing where. So we can go back to the browser, go to the API, and so I'm going to open a new tab, go to the developer, and let's look at the source code. Here's the browsable source code. I'm going to type image plus, so it brings me directly there. And sure, via Google, why not? There it is. So here it says public class image plus implements all of these interfaces. Great. Now, where are the listeners? I don't know, so I'm going to look for them. There's a vector of listeners right there, and it's private and it's static. What this means is private is, in principle, you shouldn't access it, and it's not available at compile time for this Java program. In practice, you can always access it, and I'm going to show you right now how to do it. Static means that it's independent of any instances of the image plus. So whenever you create an image, that's wrapped in an image plus class instance. So the class is basically the template, and the instance is an element of that, right? One that exists that you created. So the static means it's common across all of them. It's essentially a property of the namespace image plus. And that's something that Java does horribly, which is it mixes together the namespaces with the classes. But this essentially is a namespace that also happens to be a class. And so this is a property of the namespace, this one right there. And this means we can get it. How do you get it? Well, we have the name, right? It's called listeners. Very good. Let's get it. So from here, what we would do is the following. We need to get that field. It's a private field of the image plus namespace. So image plus, we're going to do, that's the class. So we're going to say get declared field, and we know it's called listeners. And then this field is private, and therefore we're going to say set accessible. This is a reflection API, by the way, for Java, to true. And now we're going to say field get. So our listeners, let's remove this here, is actually this field get. And get for which instance? There is no instance because it's a static method. If we do that and we say print listeners, what do we get? Here it is. So we get a list, which is why it's in square brackets, of a class called or Python proxies, whatever, but it's the file open listener. This file open listener, remember, is the same class we had here, file open listener. Okay, so now that we have it, we can get rid of it. So how do we get rid of it? Is basically image plus remove image listener, listeners, the first one. As we run this now it's gone. So it will no longer print anything. So what I've shown you here is basically how to get any static field you ever want from any class by using this approach, get declared field and the name of the field. If you don't know the name of the field, you could call get declared fields and get a whole list of them. So that was the other way in which we could have done it. That can be very big. And so sometimes you just don't know what you're looking for. Just to demonstrate that further, I can push here persistent. There's something it didn't like. I'm going to ignore. And now here it opens a REPL. This means, I forgot what REPL stands for, but it's basically an interactive prompt. And what we can do here now is say print, basically.
Sorry, I'm following and writing along as I go, and I'm getting the error that the name image plus is not defined.
Right.
Oh wait, no, actually it's in the top line. That's what I had.
Yeah, this means you didn't import it. So very recently, I implemented auto-completion for Java classes into the script editor for Python scripts.
Yeah.
It may or may not be in your Fiji, depending on whether you did an update basically close enough to the session. Otherwise, you may have to write them by hand.
I updated
Yeah, I think I
them, like,
identified the bug.
today,
Thanks.
and I don't have that autocomplete.
Right. I don't know whether it's already in the updater or not. If I run the updater, what does it say? Because it takes some time and when I push it to when it appears into the updater. The updater will come up in a moment. As soon as it finishes going through. No, it's still not there. Yeah. You can install it from Maven, but maybe we can touch that in a moment. Let me finish this. So now I made this persistent. I have a prompt in here. If you don't know what this is called and you have a guess, you want to have a guess for what it is, you can always do this and say fields equals, sorry, I need to import the class. So say from ij import image plus. I push return. Now it becomes up here. So it's been imported. It's just like a prompt, command prompt. And so now we can say print image plus get declared fields. And this gives me a list of 10 bazillion fields, right? So now I can do for field in.
How do you get that IDE for Python in the macro Fiji? I don't have that.
You mean like this?
Yeah.
File new script?
No, not the file new script. That I have the file new script. I have the script editor, and then I have the output window, but I don't have that interactive.
Okay, right. So
environment.
you may have it like this, right? You have a window at the bottom. That's right. So if you push this little, you don't have to push this little arrow, but I find it more convenient because screens tend to be wider rather than taller. As I push the little arrow, you get this. And then notice there's a little persistent checkbox.
Oh, the persistent. Okay. Yeah. Okay. It was the persistent.
Yes, what the persistent does is two important things. One, it gives you a prompt. But the second one that it also does, and we'll go back and demonstrate the first example, is that it keeps around everything that you've executed in the script, which is very convenient. But now let me finish what I was doing. So here you can do now for field in image plus get declare fields. And then we can say if field, I think is get name, basically contains, meaning find in Python, listener, because I don't know exactly, it's going to be called something like that. We can say then print the field. And it printed many. Oh, sorry, of course, because I need to say if this is bigger than -1, essentially. There it is. Private static Java util vector ij image plus listeners. So if I had not known and I wanted to guess, you can always get a list of all the fields a class has through the prompt, which is annoying. This should be in the autocomplete, and it will be soon enough, but just not yet. Right, so having shown how to remove the listener, which unfortunately my J is missing a method, which is give you the list of listeners, so this will be a lot easier. Let's go back to the first program that we ran. And so the appropriate way to run this would have been, and let's close this image now, is to click the persistent checkbox. And now as you do that, when you run it, it installs the listener and nothing happens except now, if you say print listener, there it is. And because it is here, of course it will react when you open images. So we can open again, this image, for instance, and there it is. It printed image blobs, right? But now because it's here, now we can say image plus, which we don't need to import because it is imported. This is a persistent of this entire script here on the left. So image plus is already imported. We can say remove image listener, and we gave our listener, and that would do it. So as I open another image, the listener should be gone. Let's open yet another one. Yep, now we didn't print anything because the listener is not there. So running the scripts under persistent is very convenient because it executes all the way until it runs into an error or the end of the script. And so then you can, basically, if you loaded a very huge data set, it's still there. You can just fix the script and execute. And so another way in which we could have done what I just did is to type it here. And now what I'm going to do is execute only, I'm going to comment it out to make it easier, okay? And say, I run this. This has started. I'm going to clear. Let's open a new image to demonstrate that, yes, indeed, it worked. There it is. It prints image blobs, right? But now I can uncomment this, select this line, and say, instead of Control-R to run, I can do run selected code, Control-Shift-R. This only runs this line that is currently selected. And so as I open again another image, this image no longer prints because we've removed it. Now you see the utility of this persistence checkbox, right? It basically gives you an interactive session into programming into Fiji. Right. So now I think I answered your question 10 times over, but that's good. That's why we are here. So let's go back to this one. What I was trying to do here is let's create a new window. I'm using the swing library, okay? Why I use this library is because it works and it's reasonably complete. It has powerful components to make our window. And so here, for instance, I'm going to do a JPanel, and to this panel, I'm going to set preferred size, and this is going to be dimension from Java out. There it is. And this dimension will be, I don't know, 512 by 512, which is numbers that programmers like a lot. And now we say frame, get content pane, add the panel. This panel has nothing. Now what we need to do is pack the frame. When you call pack, what it does is it recursively tells all the components of that frame to choose what is their ideal size that they want to render at. And then we say set visible. I really need autocomplete here. To true. Same thing, I'm going to make this persistent. And I run it. Click run. There it is. That's our first window, which contains exactly nothing. But that's exactly the point, right? It's empty. It's empty, but we have a handle on it. Because remember, if I put frame here, sorry, if I print frame here, this frame exists. We have it in our script interpreter. So now we can enrich this frame. So what do we want this frame to have? Well, how about we can add buttons to it, we can add tables, we can add labels, and we can lay out how these labels should look like. So let's try to do something very simple. Suppose we have what's the simplest thing we can do here? We can add a bunch of buttons. And let's see. This button would be to, I don't know. What would this button do? This button should do something interesting. God, I'm blanking out at 9:30 p.m. Okay, the bottom line is we need a button. This button will have a name. This name will be click me or lounge something. How about open an image? Right. Now, the first thing we need to do is we call our panel and we say add this button. But now this button doesn't do anything. So how can we make this button do anything? Is again the listener model, just once again. So what kind of listener does the button need is an action listener. How do you find that out? Well, you can double click on these, go to Tools, Source, JavaDoc, and here's JavaDoc for button. And as the JavaDoc loads, we'll scroll down. Here's the field summary, which are probably a bunch of static fields. Finally, constructor summary tells us how to build the button. It can be bound to an action already. You can have some text. You can give it an image as an icon. And then which methods it has. There's all kinds of methods. And none of these methods seem very useful because it turns out that a button is actually a class that extends another class called abstract button that does a lot of things. And one of the things it does is it adds an action listener. It has many other listeners, but this is the only one we care about right now. What is an action listener? I click on that, and it sends me here. Public void add action listener, this action listener class. Okay, as I click at the action listener class, it opens the interface, action listener, which has a single method, action performed, giving us an action event, and that's it. Invoked when an action occurs. That's all you need to be able to react to somebody clicking on your button. Very simple. Right, so let's do that. So we have a class. This is our action. And this is an action listener, which is this one. And this was action performed. And there's an event. Then we said we wanted this to open an image. How do we open an image? We can always say, print button was clicked, just for the record. Then to open an image, we're going to say IJ, oops, sorry. There's a static method in IJ, which I want to import, called open, that I believe if it's without any arguments, it will do the right thing. If it fails, it doesn't matter. Right, so we've done that. If we do this, now we can run this bit. So this was Shift-Control-R, and it complains. Of course, the button is not defined because the part that I need is at the top. I'm going to first execute the imports, and then I'm going to execute this. Okay. Why don't I see the button in my frame? It's because we haven't repainted it. As I drag it, it repaints again. I could have done that programmatically here by doing frame repaint or frame pack. That would have been the same thing. Now we have a button. As I click it, did anything happen? No. You know why nothing happened? Because we defined the class action that extends its action listener interface, implements it, but we never told the button to use it. All right, so button add action listener, and here's our action. So we give it the action. Now, if we run these two things, that would help. So Shift-Control-R, I run this. What happens now to our button? Hop, there it is. Open an image. Beautiful. I don't need to open an image. I'm just going to push escape to cancel this. But basically, what I'm demonstrating here is this incremental graphical user interface design. You build it as you want. So Jython has very nice things built into it to do graphical interfaces. For example, all of this is an enormous amount of, pardon my language, bullshit, just to do something simple. Jython decided that this was not the way to go. They wanted to make it much simpler. So we're going to add another button. And this button, first we're going to define an action. So our action for button 2 is simply a function that takes an event. And in this function, we're going to say, OK, just something very simple. So now as I create the button, I can give it a title. And this title will be our OK button. Simple as that. And so now I can do something that in Java is like, what? You take a shortcut and you define a keyword argument. So Python can have positional argument as well as keyword arguments. And this keyword argument is the name of the interface you want to implement, of the method of the interface you want to implement. And so now I say this action performed will be my action button 2. So whatever you were going to execute for the action listener, pass it on to my action, which is why my action takes one argument, which is the event. OK, so if we have that, our panel, we can add our second button. And we can call the frame to refresh itself. Right, so let's see. Let's pick this up. Actually, I need these three things. Shift Control R. All right, here's my button. Do you see that it says OK? As I push OK, there it prints. OK, there you go. Basically, what Jython did here for us is it took all of this ceremony, threw it all out, and said, look, what really matters is the method of the listener interface that you wanted to implement, and gave us that shortcut. As simple as that. And you can add here, commas and more, methods for interfaces that this program, that this class is able to implement. Okay, simple as that. Now what we're starting to see is we have two elements in our interface, but one is next to the other. How do you change the layout? We actually never defined the layout. We're just adding components to this graphical interface. So let's do that. If we have two buttons and they are one on top of another, how can I add a third button? Well, let's see. I'm going to make it more interesting. And what I'm going to do now is I'm going to create, I'm going to steal the canvas of an image. Instead of creating it from scratch, it would take too long. I'm going to take this, and now I'm going to say, OK, here. Our image plus, which by convention we call it IMP, is going to be ej.getImage. That's the one that's currently open. I mean, you can get this from many places, but that's fine. This thing has a window, which is the getWindow method. I happen to know. And it has a canvas. And the canvas is the window getCanvas. So this canvas is nothing else than this. It's the image that is right here. I could create a new one. I'm just taking a shortcut also to show you something crazy, which is you can move components from one window to another. So now I'm going to do panel add the canvas. And as I add it into one frame, I will be removing it from the other. So let's see if this works. There it is. Ta-da! I stole the canvas from this poor image window into our window. So I have three elements in there. Of course, this canvas still can draw ROIs. You can paint on it because it's just an image canvas and has all the listeners implemented for all the tools that ImageJ offers. But of course, we don't have the label, which we could have stolen if we wanted. And now these buttons. The point is now I have three things, and I want to sort them properly. Instead of trying to show you the various layouts that I could use, I want to show you the most powerful layout. It's really the only one that matters. And it's basically a grid back. And so it's called the grid back layout right here. And then how it works is it uses a bunch of constraints. And I'm going to put it as C because this can be very long. So the grid back constraints is another instance. And then what can we do with this now? Well, first of all, we're going to tell our panel to set a layout. And this layout will be our grid back. How does the grid back work? The grid back is literally a table. And every cell of the table has coordinates. And so if it has coordinates, we can say, OK, this is the grid X will be 0, which is by default 0 anyway, but I'm making it very explicit. The grid Y is 0 for the first component, and then this component will be the image, for instance. And then I want to put the buttons to the right so that I have the image on the left and the two buttons, one on top of another, on the right. So there's going to be two columns, right? One column with the image and another column with the two buttons. But of course, our image will have a grid height of 2 because there are two buttons on the other side. If it doesn't become clear now, it will become clear in a moment. Right, I don't want it to resize, so I'm going to do the fill constraint. It's going to be, this is the grid back constraints, come on, none. I don't want this to resize at all. And the anchor is where do you want it to attach within the cell as you resize this window? Well, I want it to attach to the top left. So I'm going to do the same thing. Grid back. Wait, this is wrong. Grid back constraints. Goodness, I didn't even know the other one. Okay. So this one would be towards the northwest, so at the top left. So with that, now I can do grid back set constraints for our for the image we set, right? So for the canvas, and the constraints are the C. So this can be a bit verbose because you have to define how you want every cell to behave. So now we're going to do the same thing for the second one. So let's put a comment here. Basically, canvas at top left. Now we want the first button at top right, basically. So this would be the grid X would be the next one, which is 1. The grid Y doesn't change, so I don't need to change it. The grid height does change. This becomes only 1. The fill also, keep the size of the button. I don't want it to stretch. Although, it would be fun to see it stretch. So we're going to do grid back. Let me see, grid back constraints, horizontal. So it will stretch to horizontally. And then this means I want to give it the weight to fill in all the space possible. So that would be 1.0, maximum weight possible. The anchor is the same, northwest is good. Right, so with all that, we can now do the same thing. I'm going to copy this, paste it here, and say, okay, that's our button. What did we call the first button? Was button 1? Just button, okay. Okay, then how about the second button? So this we want at bottom right. And so now the grid X is the same, but the grid Y changes to 1. This will be grid X1, grid Y1. So I'm reusing the C, only updating the methods that I'm not. Otherwise, I would have to specify everyone. The fill is the same, the weight is the same. We're good to go, basically. So all we need to do here is button 2. And I think all we need to do now is frame pack. And that should do it, unless I've mistyped something, which is possible. So let's see. Let's execute this and see what happens. Okay, what happened is that the grid back layout is not, of course, that we don't want at all. We have to execute the imports. So again, Shift-Control-R on the imports. And now we take this, all the grid back, execute it. Wait, what? Oh, goodness. I've been typing this completely wrong. So the set constraints gave me an error that said that the second argument of the function was not a constraint. Yeah, indeed. It was not at all. Okay, so let's rerun this. Okay, and now you see immediately changed. But the buttons are nowhere to be seen. There they are. Since I said that I wanted them to fill on the horizontally, they fill enormously, right? This is the first one, this is the second one. Here's my canvas. So basically, with using this method, you can define whether you want your elements to stretch or not. And so I said the image, I don't want it to stretch. That would be very funky if it was to stretch. So I said for the image, the canvas, that I don't want it to stretch at all. So fill none. And then whereas for the buttons, I said stretch them not vertically, only horizontally. And there they are. So I think we should stop here with this very simple example, which has already demonstrated how to do a listener on UI components, how to incrementally build your graphical user interface, how to add, say, a canvas to it, which you could have created anew, or simply steal it from an image, which was a bit crazy, but it was a convenient thing to do for this tutorial. And then as well, how to lay it out in a way that makes sense. There are many examples for this layout. And in particular, in my website, I do have one. And so I'm going to go there now. Whoops, that's the wrong one. This is the right page. I'm going to look here now for grid back layout. Right, and then somewhere there, yeah, let's look for it again. No. Where is this? I don't want that one. Here. So there's one of these examples, which is actually the example on table with annotated history, which we'll touch on in a bit, where we have basically a grid bag layout configuration. So now you know what I'm talking about, right? In this particular case, we have a table, we have a search text field, a file, the file path, an open button, and several other things. And so some elements take a grid height of 2, some elements take a grid width of 3, and so on. And this is what gives you this particular graphical interface. So in this program, you'll have a very concrete example of that. Just to reiterate, what we're talking about here is the table with annotated history of opened image files. Right, so now what I wanted to do is open exactly that example and walk you through what is it doing. And maybe before that example, I should touch on the simpler one of managing large collections of files, which likely you'll be more interested in it. So I'm going to close this frame. I'm going to close that frame. And we can open a new one. So let's see.
Sorry,
Somewhere
can I just
in there,
ask?
yeah, go ahead.
So whilst we're following you, are we going to be able to have access to some scripts similar to this? Is it on your website, or are you expecting us to sort of follow along and write the code at the
So
same
if you
time?
want this, if you want these simple scripts that I just typed in, I can save them. So let me see. I can save them and then send them to, put them in a Dropbox for all of you. So here, I'm going to go into my desktop. I'll create a folder. Let's call this the I2K scripts. And this script was basically the JFrame with canvas, right? Oops, goodness. And buttons. I'm just going to save it in there. And then this one here was the image listener. Let's save that one there too. So we're going to call this the image listener.py. There it is. And I think there was a third one. This was the reflection. So in which we can also then copy this into here, just for the record. So let's save this. This would be accessing fields, class fields via reflection. But it's a good point. I should save these things.
Yeah, and then if you can share them in Slack, because I expect everyone's in the Slack channel that was shared via email, so that could be a good.
Yeah, I can also send. That's right, and I can also send an email to all of you, with all of these scripts. Yeah, that's a fair point. So actually, something I can do as well is I can select. Where is it? Huh? Why doesn't it show anything? Wow. Somehow it doesn't want to open my home. Sorry, there's something funny going on. One moment, please. Uh-oh. My computer cannot even list files. What went wrong just now? I suspect there's an enormous amount of small files being created somewhere. Oh, come on. By who? I'm sure it's not this. Now it works. Okay. Sorry, I wanted to add, so there's this feature here where you can add buttons, except it doesn't. Well, the demo gods have been invoked, and for the first time in my life, I cannot list my home directory in Fiji. How? Oh, there it is. What exactly is going on? It's beyond me. But this is the I2K scripts. I'm going to open it. So now basically I have them here, and I will keep adding more as we go. Right, good point. So I'll take mental note of doing that when we are done. Now, I wanted to move on into this script for basically managing large collections of files. Instead of doing it from here, I've prepared already this script elsewhere. So here what we have is a virtual desktop into my work desktop at the LMB here in Cambridge. What I'm going to show you is first, what is the UI that we expect? So this screen is a bit busy, but I hope you can see that the window that I'm moving has a very small title called File Paths. And then in it, we see a search label. That's one component. Here is the text field where we can type what to search. I'm going to clear it. Enter a valid search screen. Sure. Right. And then what we see in here now in this table is this huge, enormous amount of files. I think at the last count, there were some maybe 15 or 20,000. I lost track of that order. I don't think there's 100,000, but there's a number like that, in the tens of thousands. And so at the very bottom, you notice there's also a base path. What does that mean? So what I've created here is a program that I'm going to walk you through slowly. But what it does is you give it a text file that contains for every line a file path, a relative file path to an image or to a file. But it should really be images. Why a relative file path? Because I'm expecting the number of files that you have is so large that you're not going to have this in your laptop, but you may access it from your laptop. And so this means depending on where you mount your remote file share, the first part of the file path will be different in your laptop, in your desktop, in your coworker's computer. Everybody will mount this in a different place. And so if you generate these file paths as relative, in order to open them, you need to tell it, okay, relative to what? And this is what this base path concept means. So in here is the home Albert Larval screen. This is where I mounted this file share that contains tens of thousands of files. And then because it's tens of thousands of files, what I'm not going to do is try to browse them one by one. And what in the first place, if I can backtrack a bit, what motivated developing this very small graphical interface is the file share is slow. It's mounted over Samba, over network file system. If you have to go into the command line and search, can I find a file that has this particular name that contains this genetic driver line, there are image, and I see here in the right one of them open, it takes time. And so instead of searching every time, what you can do is search once and dump all the files into a text file. And then you load that. And searching that is pretty much instantaneous. And I can search by string, meaning a subset of these file names, or I can put a regular expression. Regular expression, I have to put a backslash first, because that's how I implemented it. And then I do, okay, 72 F11, and I only want to see, this is a Gulf line that I'm using, and a dot means now match any character after that, and then any number of times, so I have an asterisk, and then I wanted to finish with LSM, which are basically these laser scanning microscopy Zeiss files. I push enter, and now suddenly the table is a lot smaller. Notice here. And so notice as well, I captured files that are compressed at .lsm.bz2. I don't want to open these files. So I'm going to put here now a $sign that says, this should be the end of the string. There should be nothing else beyond that. So I push return again, and now I have an even shorter list. And the only files that I have listed are LSM files. And now these LSM files, remember the concept of listener? I added the listener to this table so that now I can double-click one of these things. And here it says opening, and there it is. Now it opened our file. This file is just a stack, and we can browse the stack normally. It's just an image stack. Essentially, what I built is a way to do file open, but for tens of thousands of files very fast, finding the file that you're looking for quickly. this is one aspect of managing large collections of files. You don't want to spend minutes looking for the files, which is something you can easily do if you're not careful. So I'm going to close these files and go back to the script editor. This is a script called tabulate file paths. And this script exists both in the Fiji Python tutorial, somewhere in there, but also in my collection of scripts. And so if you go to
the
GitHub,
link on the chat. I posted the link on.
Thanks. So if you go to my
would it
sorry,
be excuse me, just a quick question. When you were talking about the numbers, the tens of thousands of files, could we in that preview add just like a line below, just for example, numbering the files that are currently on display? Would that be hard to do, or I'm guessing not?
No,
but
it would be very easy to do.
yeah.
That's right. Yeah, we could do that now if you want. It's a way to iterate. But basically, we'll get back to that. It's a good question. So this entire file exists.
Yeah, okay. Yeah, I'll ask.
Okay, never mind. I just wanted to show you that this exists in GitHub. Now it's there in the video, you can see it. And I think that Mark Corrales pasted the link onto the chat.
Yes.
Right, so going back to your question, what you're saying is, can I see how many files were matched? Yes, I didn't bother to add anything, but basically what you could add here is a label somewhere at the bottom or whatever that tells you matched 120 files or matched only 6 files or whatever. Yeah, it would be easy to do. You could also add here another column, which would be the index of the files as you see them here. And then by the index, the first one will be 1, and at the bottom, you'll know how many you have as well. This table is simple. It only has one single column with a file path, right? So what do we need to make this work? So there's a whole bunch of prerequisite steps. The first one is you should find all the files that you want to have into a single text file. And the way I did it is simply run a command line program, which is bash, find -type, file, and then print the full path and pipe it into this file in my desktop. That's a simple way to do it. If you're in Windows and you don't know how to do this, from Python, you can do it with OS walk and then create the file directly from Python. We can do that later if you like, but I'd rather not linger on this at the moment because there are many ways to do this.
Yeah.
So the next one is, of course, a bunch of imports, which I'm not going to touch on because they don't matter. It's things that should be added automatically, and if you don't yet have the updated script editor, soon you will. And so that's one way to solve this problem. Let me see. I'm going to now click the little arrow here to make my window bigger. Then I want to walk you through how I build this script. This script is not terribly long. It has in total about 300 lines. And the last 30 or so are just to change the font of the various components. So it's really not that long. So let's go through it. There's all these imports, whatever. Then what I've done here at the beginning is add a note that says you should edit here and change the file path to the text file and also the base path. So I have here various examples that I use. For instance, at my LMD desktop, I want this particular file for this particular base path. But if at my home laptop, I mount my file share via secure shell file system, and then I have a different way to do it, right? This depends, again, on how everything is done. So this here is to basically make sure that the text encoding of the file that we read is in the same encoding that I expect, which is this UTF-8 standard format. Because if you're in Mac or if you are in a Windows, most likely you will have maybe Latin 1 or something else. UTF is a standard that ensures that the file paths are conforming to the standards that, say, Java expects. So this snippet here is incomprehensible unless you've had errors that told you, like, okay, there's an encoding error in the file paths. Because particularly Windows users like to have spaces and slashes and all kinds of things in their names. So you want to make sure, in the file names, to make sure that you are reading it correctly. So then, what else do we have? I'm going to ignore this for now, and I'm going to focus on this. What is this? We have a table in there. And so let's build this table. So from scratch. So what do we need first? I'm going to use the script as guidance, but basically, we should try to recreate it from scratch to see how you would do this. So first of all, I'm going to need a frame. Actually, I'm going to need a table. And because I'm going to need a table, I'm going to need a way to express data in that table. And this is done with a table model. So I'm going to do a table model. The model here in the parlance is the actual data behind any one of these user interface components. So the table model, I'm going to make it extend an abstract table model because the interface would force me to implement every damn method, and it's too many. And so instead, I'm going to use this. And then which methods do I need? Well, quite frankly, I've forgotten. And so since I've forgotten, I can go here and say, okay, I can try to discover them, basically. What are all the methods of this interface? And we can print them. And so we can say from, Java X swing import, actually swing table, I believe, import the abstract table model. And then we can say for method in abstract, goodness. I'm just doing manual autocompletion, basically. Get declared methods. Just print the method, which will print some information on it. And it doesn't like that. Why it doesn't like that?
Abstract is written wrongly in the second line.
My goodness, thank you. Good catch. Okay, there it is. So let's make this bigger and let's look at what we have in there. There's quite a few of them. So it starts here and it shows, okay, there's the file table structure change. These are listeners, the column name, column class, set value at, if you want to edit that particular field, the listeners that it has, which we don't care at the moment, and then what else do we see in there? These are the ones that this defines. Of course, I made a mistake. What I really need is the interface table model. And this interface now so I'm going to clear this and run this again. These are the methods that we actually care about. Column count, row count, because this describes the shape of our table. Okay, so let's define one. How many columns? How many columns are we going to have? Remember, we have to have a self in there. So we're going to return. We want 2, right? Because one of you said I would like to have a number in there that tells me where things are. So it's going to be 2 columns. Okay, fine. Next table. Get row count. How many rows are going to be there? I don't know. It depends how many files do I have. So I need a data structure, say the file path, which is a list. And then I'm going to need as well a second data structure, which is the filtered file path, which is a different list. And this table is dynamic, so what we need in here is the filtered file paths. Sorry, this is Python. So we need to return the length of that. Great. Now, what else do I need? How about the column name? So the column name at index of the column, and these are 0 index. So we're going to do, if, sorry, not int. This would be index. So for the first one, we return simply index. And for the second one, we return the file path. These are the titles of the columns of the table. Then what else we have in here? Set value at. And this takes the value. So this is going to be the value to set, and then this is going to be the column index, the row index, and the column index. So I'm going to pass. I don't want to edit this. I don't want this table to be editable. Pass means give a empty implementation. Okay, what are we doing next? Oh yeah. Remove table listeners, whatever, we don't care about, because we're actually not implementing the interface. We're actually extending an abstract class that already implements a bunch of table methods. That makes it simpler. I just wanted to find the key ones that we really need for our table. And so this one would be, is cell editable at where? At, again, row index and column index. And I see that I don't need to type this. This could have been A and B, it doesn't matter. And I'm going to return false because I don't want the cells to be editable. So this is our basic minimum data structure. So now with that, we can create a table. We can create a model separately. Do we need to? We don't need to. So let's create a table, and this table now needs a table model. So which I instantiate by adding this double parenthesis at the end. So this table model is this, right? Okay, so that's our table. And our table doesn't have any data because we didn't load any data. So how about we load some data? Let's see. I'm going to need the text, basically the list. What are we going to call this? I think I call it text path. And I'm going to copy the one that I have there. So I'm going to need these two things, basically. I mean, if we were to show this table would be empty because the underlying data structure is completely empty. And by the way, there's something we haven't done, which is the get value at. Very important. We missed the most important method, which is how should the table be populated. Right. And so what we're going to do here again is the same thing. If the column index is 0, we return the row index plus 1. That's basically the position, because they're 0 based and I want them 1 based. But if otherwise, and we return what? And there's only 2 columns, by the way, so we don't even need an if in here. So then we just, for the other one, we return, which this reminds me, by the way, let's make this future-proof, sorry. We return nothing otherwise. Let's do this. So I'm going to do this, what I call defensive programming. I write it in such a way that if I modify the table later, this will not fail. So now we return the filtered file paths at that index, at that row index, sorry. And otherwise return basically nothing at all. I return an empty string. Right, if I'm missing any methods, this will complain when we try to run it, so it's going to tell us. So I have that. Now, next thing, I need to read this file to load all the text, all the file paths. So I'm going to go here to the top and say import auth. Auth is a Python library that is common here and elsewhere. It's just plain Python. And so now we can do, okay, our data structure above was called file paths. We can redefine it again, it doesn't matter. File paths will be what? Basically let me see, I don't know exactly what this will be. I'm going to put this for, what are we reading? We're reading lines in a file. Wait, I think I need to do more things. To read this safely, we need to do something like this. From future import the with statement, which exists in Python 3, but in Python 2 you have to import it manually. And now we say, with open the text file for reading only as file f, whatever. Now file paths is basically, is it lines? Do you guys remember? I've forgotten. Where do we read the file? It's probably here at the bottom somewhere. Come on. I've forgotten. Open. Here it is. I see, just for line in F. Okay, fair enough. And it wants to remove, of course, the last one. Okay. So line without the last element. So line will be a string for line in F. There you are. We've read the entire file now. So now that we have some data in there, we can try to load it. So now we can create a minimal system. So the frame would be a JFrame, like that one, which is basically our collection. And then we can create a panel. It's always useful for later adding more things. And so the panel is a JPanel, which is empty. I'm going to move this up to make it more easier. And then to this panel, we add the table. This table does not have any listeners yet, so we cannot react to it, by the way. And now we call frame. Well, we need to give some dimensions to the table, by the way. We never did. We want the table to have some preferred size of that one. Dimension, I don't know, at least what? 600y by 600 high. We add the table, we pack the frame, and we show the frame. And now let's see which errors have we made. This should run. Where is my frame? Ah, the frame has nothing at all. So it must be extremely small. Yeah, there it is. Okay. I'm going to close it. I made a mistake. I didn't add the panel. I don't know if you guys realized. I added the table to the panel, but not the panel to the frame. I disposed of it, but all I had to do actually was do that. There, oops. What happened here? See, now it's complaining that we didn't implement correctly one of the methods. In particular, it's saying that the get row count takes no arguments, but one was given. That's right. We forgot the self. Oops. Okay, let's close here. Good. Now, let's stop making this persistent. Forget about that frame. Do it again. Okay. Why I don't see anything is a good question. Where is my table? Panel add table, get from add panel, pack. We put, oh, of course, because if you guys realize, we are using here the filtered file paths, not the file paths alone. The filtered file paths contains nothing. So what this table does is exactly what we told it to do, which is to show a completely empty table. Right, so let's take the filtered file paths and let's give it a content. And this content will be the file paths. Right, I think that should do it. Goodness. Now, if we refresh this, yep, there it is. Here's now our humongous table with all the files in there and all the numbers in there. But you'll notice other things. For instance, there's no scroll. We cannot scroll the table yet. We gave it a raw table with more rows that fit in the screen. That's not a good idea, right? So let's close that. How can we fix that problem? Instead of adding the table directly to the panel, what we're going to do is create a scrolling JSP, basically. This is a JScroll pane for the table, and that can scroll the content of the table. And this hopefully was imported, was it? Yeah, great. Ah, goodness, I keep wanting to save this. Let's try it again. Did it run? There it is. That's much better. Now I can scroll, but actually it doesn't scroll properly because we've given the table a certain size, but not the scrolling pane. So we gave the dimensions incorrectly. We gave the dimensions to, which we don't need to close it, we can fix it like that. You notice here that we gave the dimensions to the table, but we should have given the dimensions to the scrolling pane. It might be easier to just close it and then make sure that the scroll pane is something we can reach easily rather than having to go through all the nested components. That's the scrolling pane. And then this preferred size is not for the table, it's for the scrolling pane that actually encloses our table. Right, if we do this, I believe this should look better now. Yep, there you go. Now we can go from file number 1 to file number 70. Oh my God, 735,000 files. I think when I said tens of thousands of files, I was counting only the LSM files.
A bit off.
There is almost 1 million of files in this particular folder. Okay, there it is. And that was fast enough. Then, of course, these columns, we didn't do anything about it, so it only gave us, 50% of the space to each, but you can move it like that. That's our table. So as you saw, this really is not difficult to do. All you have to do is know where to find the classes that you need to build your user interface, right? And so what you needed to know is table models of tables, which express how the content of the table is accessed. How many columns it has, how many rows, what name to give to each column, and then whether you want to edit this, no, I don't want to make it editable. That has other uses. And then how to retrieve values for every cell of the column, by row and by column, right? This is as simple as that. So now if you want to add things up to this, like let's add a filtering system, right? Or let's add the ability to open a file, right? How do we do that? Let's see. What we want to do now is be able to double click on one of these rows and open the file with ImageJ. So what would be one way to do that? I've forgotten. So I'm just going to go and look at a bunch of examples. And I'm pretty sure this is the row click listener. Yeah, it is. I'm just going to copy it whole. Right, so what does this do? Basically, I define yet another class, and this class extends the mouse adapter. Given that this mouse adapter is not imported, I'm going to import it like this. There it is. OK, now we have it. And then this mouse adapter is essentially a mouse listener that has all its methods implemented for mouse clicked, mouse pressed, mouse released, etc. I don't care about the other ones. I only want the mouse pressed. And therefore, the adapter basically provides already empty implementations for every method of that listener interface, right? Then I don't need to have a constructor here. That I was being too much of a purist in there. And then the event is a mouse event. If you don't know, you can always print it and find out. Then this event tells me how many clicks. So when I double click, it will do something. Where is my table? I can get it from the source. Where is the model of that table? I can get it from the table. I have it here as global variables because I didn't enclose all the UI making into a function, which would be a cleaner way to do it. And that's how it's done in the example script, is tabulate file paths. It doesn't matter. That's one way to do it. I can just get rid of this completely because we have them accessible as global variables. Here is our table, and actually the model is enclosed in the table. We didn't make it accessible. Do we need it? Probably not. So now what we do is row index is table row at point for the point at that event. This gives me the index. Brilliant. If I have the index, I can get the data. Okay, where do I get the data from? So I'm going to ignore this for now. The data will be here. We need to have basically the image file path. How does that look like? Well, that's the base path. Remember the base path that we defined here? This is where your file share is mounted in your computer. Plus the model of the table. So table, get model, and this model can give me data, right, at a certain place. It says get value at. That would be one trivial way to do it. Get value at. The row is the row index. The column is the first column, meaning the second, but it's zero based. If I do it this way, what's going to happen? In the first place, in Windows, it may not work well, and so on. It may also not merge these paths correctly. So instead, I'm going to use a library called auth path join that will take the folder where the file is and then the file. And it doesn't matter that the file is a file that has folders in it. This will do the right thing. This will join the base path and the relative path together appropriately in an operating system manner. And so then once I have this, what else do you want to do? I need to open this image. What would happen if I say, okay, good, brilliant. IJ, let's import IJ, open that file. So what would happen is that the event dispatch thread that is running this event will be tasked with opening the file. And the file can be, a 2 GB file that takes 10 seconds to open. During these 10 seconds, your entire Fiji will be frozen. So that's a terrible idea. So Fiji runs many threads. There's a thread for the events, right? There's a thread for the menus, there's a thread for this and that. We don't want to do that. So we have the option of creating a thread and running it just here. Let's do that. So let's create a new thread. And to do that properly, I need to define, so all functions in Python define the runnable interface that threads can execute. If this is a bit too much, listen for a moment. So we define a new function, and this new function will do the job for us. And it will read this variable, which is here in its own scope, so we can read it. And then now what we do is we say, okay, let's create a new thread. Is this the right thread? Yes. Okay. And then this thread will take our open image as the runnable, because all functions in Jython implement the runnable interface. And then I'm going to say start. Just do it. But if I do that, this thread inherits the priority of the event dispatch thread. And that, at least in the single core machines which don't exist anymore, would be a terrible idea. So instead I say, okay, this is my thread. I want to set priority to thread norm priority, not the event dispatch thread, which is a privileged thread. And now I want to start it. Right, so if I do all that, now when I double click, basically I'm creating a new thread that opens the image. Brilliant. Let's do that. So let's see if this works. I'm gonna let's just run it. Okay, so this run, oh yeah, of course, it will do nothing at all, because guess what we've done? We have not added the row click listener to the table. So the table doesn't know. This is add mouse listener. We need the row click listener instance. So I need to put double parentheses at the end to create a new instance of that class. I'm just going to do this. So Shift-Control-R to execute only that line. Now our listener exists. OK, so let's find a file that I know can be opened. And the table is not. Of course, the table has its preferred dimensions, and we didn't use a grid layout that makes it stretch. So it's going to be a bit difficult to even know which file is this. OK, whatever. Let's try to open it. Will it work? I'm not sure. Did anything happen? Where is Fiji running? No, that's not the wrong computer. Is it running here? Yes. And nothing happened. This could be a file that Fiji doesn't know how to open. So, God. OK, you see, we have a problem. We need a proper layout, because otherwise we cannot even read the files that we're looking at. All right, let's fix the layout. So like we said, we have a grid back, which I can just call grid back. The grid back layout, and then we take our panel and we set the layout to it. And now we need the constraints, which I'm going to call C. Grid back constraints. And what do we need now? Now I need to define, so the grid X, grid Y is 0 by definition. There's only one component in there anyway. And what I want to do is I want to do fill equals grid back constraints both. And so that as I stretch the window, the table will stretch as well. And so now, to whom do I assign these constraints? It's basically the grid back layout set constraints for the panel, right? No, not the panel, for the GSP. This will be the scroll pane that contains the table. That should do it, if I'm not mistaken. Except, of course, we need to import these two classes, the grid back layout and the constraints. So Shift Control R. They are now imported. Now I can run this piece of code. And I can also call the frame to pack so that it relayouts itself. OK. So as I've done that, now I can. No? Why not? Huh. Did I not say panel set layout? All right. Well, now we reach a snack in which I hit the limit of my knowledge. Why isn't this stretching now when it should? If anybody has any ideas, you let me know.
Didn't you implement a restriction in the scrollable plane? We took out the restriction on the table, but then we implement those restrictions there. Wouldn't that limit the scrolling plane?
So it does by default. And so this in a way defines the dimensions of the frame, because it says, I would like the preferred size to be this.
Yes.
But I think the problem is that the weight is 0. The weight X should be 1 to like use all the available space. And the weight Y should also be 1. By default, the weight X is 0 in the grid back constraints. So we can now replace the layout by basically rerunning this. Let's see if my intuition is right. Yep, there we go. You see, just the weight was wrong. So now we can finally see which file are we looking at. Yeah, this was a zip file, which likely ImageJ did not know what to do with or is still struggling to open. So we can just scroll. We want to figure out, here's a JPEG. OK, there it is. Easy. Ta-da! So now we have a very, very simple script that loads the entire collection of 737,000 files. 707, huge amount. And then every double click will open an image. And so that's great, except you're not going to look for files by scrolling through almost a million files, right? So what's the next step? The next step is we need a way to filter this, please. Great. So let's create a filter. And after we create a filter, we're done with this particular example. So a filter would be, we need a text field where we typed our filter. And then what we type in that filter, we can either match the string, which is the simplest thing to do, or we can make it work with a regular expression. Let's see how we get there. First of all, we need a field. So this will be our filter field. Everything starts with J in Swing. That's a J text field. There it is. And it contains nothing. It's just empty. And then we want to be able to react to it, remember? So that when something happens, when does an action happen to a text field is when we push a button. So, whoops. Yeah, look, bioformats now finally figured out how to open that BZ2 file. Yeah, no thanks. We're interested in it. So the key press, remember, is one of these methods of the of the mouse listener interface. And so this will be now basically our filter table, which is a method that doesn't exist yet. Well, let's define it. Filter table is a method that will take an event, which is the mouse event. Is it the mouse event? No, sorry. This is a key event. I just happen to know that, but you can look it up. Key event, and this is from, well, whatever. Let's not complicate now. What do we want to do when this happens? Well, we want to find out which key. So the key code is basically event get key code, and then if the key event, no, sorry, if the key event, yeah, I think it's key event. I need to import this class, not this one. Yes, the Java one, exactly. There's all the keys of the keyboard. So how about enter? Enter. How is this giving me some random stuff? Did I import the wrong key event? That's the one I want. Yeah. No? I don't get it. I'm sorry. I think I might have the wrong class imported. No, it is. Okay, I'm not sure I get this, but again, we can select this, tools, source or Javadoc, and there's many key events, but the one we want is the Java out. That one, Javadoc, please. Okay, yada, yada, yada. There must be one that is the enter, isn't it? Let's search for it. God, this thing's still scrolling. Yeah, it's BK enter, exactly. I have no idea why I didn't want to do it, but we solve it by looking at the documentation, that's why it's for. So if the event is actually the key code, then we want to do something. We want to filter the table. Filter the content of the table with the text. So the first one that we can implement is simply just plain text. So where is the text? The text is in our filter field. Our filter field is a global variable in this script, so we could access it directly. A cleaner way to access it would be simply to call the event to say, tell me the source, and then get the text from that source. Because this text field implements the text component, which has a get text method, and so on. Now with this text, what can we do? Well, now we can define the global variable. And we're going to modify the global variable in one of our methods. This means we need to tell it that we're going to do so. So we say global filtered, what was that? Filter file paths? I forgot the name. Filter file paths, this one. filter file path, we're going to edit it. And so instead of being a local variable, it'll be that global one. And a more sensible way to do it, because the table, yeah, there's a threading problem. So we're going to do first filtered equals, and I'm going a list comprehension where I say path for path in all the file paths if path find the text is bigger than -1, meaning the index at which the text is found within the whole path is bigger than exists, essentially. There's an index within the string. That may take some time because there are 700,000 to filter. And so now that we are done, and actually that's true, I could just do it here, sorry. Because we're not building this piecewise. We've done this, now we need to do something. We need to tell the table that it needs to update itself. It needs to update because its underlying data model has changed. How to update the table is tricky because the table can only get updates via the event dispatch thread. So how do we do that? Easy. We're going to build a little function here that says, update table that takes no arguments. And now this table is going to be called, we're going to say, I think it's update UI. Right. And so that should trigger it. Now, how do we run this method? In the event dispatch thread is we ask the Swing utilities to do that. And so it's this JavaX Swing utilities invoke later. So once you're done dealing with this event, run a new event, which is update the table, please. And this is a pattern you will see a lot in how to update graphical interfaces. With that, I think we are done. So, except, of course, we never added our filter field anywhere. So where are we going to add our filter field? Well, we should have added, we can add it at the bottom of the table or at the top of the table. So given that we already have the table up there in the first position of the grid, we can add this field at the bottom. So we're going to say the grid X is 0 anyway. The grid Y is going to be 1 because it's the second row. The field being both, no, we want this to be, we want to constrain this to horizontal, so make the field as wide as the whole frame, but not wider, not taller. The anchor, we need the anchor to be at the northwest so that things look pretty. And then the weight should be 0. So the weight in X is fine, but the weight in Y is 0. So that this never tries to take over any space from the table. The table takes as maximum space as possible. So with this done, we now tell our layout, the grid back layout is the GB variable, to set constraints for the filter field. I really need that completion. These constraints, and now we tell the panel to add the filter field. Okay, and now we tell the frame to pack. So we have a bunch of imports that we should execute. Unless we want to rerun the whole script, which I don't want to because I have this large table already in there. So I'm going to say, okay, some of these, I forgot which ones, the text field, the key event. Nothing would happen if I was to execute imports again that are already there. So I imported this now, and now we want to add the filtering. So to add the filtering, we need to do all of this. Let's see, why don't we execute first this one to see if there's any error in it. Okay, this was happy. Now, same thing, we run this one. Have we forgotten anything? Panel add, frame pack, I think we're good. Okay, so now our table has a field at the bottom. of course, we packed it again, so it's a bit smaller. I'm going to make it wider. The field is quite small because we didn't define the font to be bigger. So it's the default font. Now I'm going to type here 72 F11 and I push enter. And as I push enter, the table now is shorter. How many? To answer that question somebody asked before. Well, there are 523 entries. I didn't filter for LSM or anything like that. I just filtered for the name of the Galfo line. That's already more manageable. But now notice that I have TIFF files and JPEG files and LSM files and whatnot. Well, I only want to see LSM files. But unless I type the whole name, it's kind of hopeless. And so what I need is a regular expression. Before I go into regular expressions, I want to ask you all a question. So I want to go back here. I'm going to pause. I'm going to stop the share for a moment. And I have to ask you a question. How many of you have used regular expressions?
They are really powerful.
I know. Yeah, raising your hand may not work very well because I cannot see all of you, but you can push the yes button. Do you see a yes button? If you go to the participants tab, okay, Mark Orales, Arturo Pimentel, Sebastian Gilbert has not used regular expressions, okay. That's also a good test to see who is listening. By the way, if anybody needs a break, maybe we should take a break. We've been at it for quite a bit right now. Okay, many people are not answering. I guess they tuned out. Okay, so many of you have used regular expressions, but there's one person or two who haven't, maybe more. Okay, there are a few who haven't. Right, so we're going to have to give a very basic and quick introduction to regular expressions. So let's go back to where I was, in which I was sharing with you my desktop here. Okay, you can see the desktop again. Right, let's put this on the side here. So I'm going to close the table completely. We'll reopen it again. That's fine. Now, notice what we did here. In this line, in our filter table method, right? Which, remember, this is the key pressed shortcut, basically, to the text field. What we did is we said, okay, take a path from all the file paths loaded from the text file, only if that path contains the string that we're searching for. That's fine, that works well, except it's limited in that you cannot say, I want to match a chunk of text and then whatever, and then a termination, meaning the extension of the file being, say, .lsm. How can we do that? Well, we can change this. Instead of filtered paths being like that, we can define a regular expression. And then this regular expression, we can do it in Java or you can do it in Python. Either way, it would work. From Python, we can simply say, and I cannot import it, so I need to do this, import RE. This means import regular expressions. So now we're going to define a regular expression with this text, because the minimal regular expression is just match the characters as you give them. And so in a way, the most simple possible regular expression is what we had done before, which is, does our string, meaning the file path, contain that text, literally? Now, let's see. First of all, we need to define the pattern. So we're going to do recompile, and this compilation will be simply the text. Whatever we're going to say, whatever's in there, consider it a regular expression. A regular expression may fail to compile, so we're going to have to wrap it in a try-catch statement. And then here we're going to do print, or rather than print, this can only fail if a regular expression is wrong. We can say ij error, and this will tell us, check your regular expression. because it's likely wrong. Right, so now we compile the regular expression, and now what we want to do is filtered path, file paths will be equal to path for path in file paths, so all the file paths, if re search text. And this returns a Boolean, meaning true or false. So that's it, we don't need to do anything else. Do we still want to update the table if this failed? No. So I'm going to take this text. Actually, I'm going to take this entire thing and put it outside just as a function. I mean, what does it matter? We don't need to define the function every time that we run this method. We can define the function outside. And I'm going to take the string utilities invoke later and put it here. Just update my table, please. And with that should work. And actually, that's a good reminder that I really should save this script because you probably guys want to have it later. So I'm going to put it here as the basically I2K table filter paths. Right. Then there's a bug in Fiji. Okay, here. Now, good. This updated the name of the file in the tab of the script editor. So in principle, this should work. Let's try again. So we run it. It opens the whole file. No errors printed. Now here at the bottom, we have the table with bazillions. So let's type a regular expression. Basic regular expression. This caret, this hat, which is very small and you can barely see. So I'm not sure how to zoom it. Maybe I'll just type it here. I'm going to type it as a comment. So this caret here means beginning of the text, the very beginning. This means, so the very start of your string. This means any character, a dot, basically. And then the star, this is a modifier for any character, for any match, for matching basically 0 or more of the previous character. And this one, which is very useful, I'm just going to define 5 or 6 that are very essential. It's another modifier for matching, 1 or more of the previous character. Okay, and then this one here means the end of the text. And so with this very basic, tiny subset of the regular expression language, now we can say, okay, I want to match, I don't care where it starts. I'm going to start directly with a text. 72 F11 is the name of a Gulf line, and then match any character any number of times, and then match the file extension, which is LSM, and then finish. I don't want anything else after LSM. So basically match towards the end of the file, so to speak, because I don't care about the beginning. I didn't even specify it. Match this plus any character plus LSM. So given this, I can copy, go here, paste it at the bottom, push enter, and check the regular expression, it's wrong. So now I wonder, what have I done wrong? This regular expression is not wrong.
Don't we need to implement like a command to specify that when we are searching on a text field, we want to use regular expressions like you shown in the beginning of the session?
Yes, and sorry, I want to look at what have I done wrong with this pattern. Research, recompile. Oh, wait a second. Of course, what I've done wrong is I've never gave it the pattern to the search. Okay, so this means this was wrong. Let's open it again. So I had made a mistake here. in that I didn't even understand how this could work. Research, but it somehow didn't give an error. Let's see now. So now it filtered too much. Basically, it does not find anything. Have I gotten this wrong again? I'm more used to Java regular expressions than Python ones. I'm looking at trying to understand what did I do here. This is partial for research. You add the pattern first and then the text. How is that wrong? Okay, see, when this happens, we can come here and say, okay, why don't we test it? So our text would be, say, blah, blah, 72F11, and then blah, blah. It would finish with .lsm, for instance, right? And then we want to now print this, research for the pattern. Wait, we need to define the pattern. The pattern would be re compile, and our pattern is 72F11 anything, and then LSM and end of the file. Okay, the pattern compiles, so there's no problem with it. And now we want to print research pattern for that text. Oh, this gives me a matcher object. There you go. So what do I need to do with this matcher object? That's this filter function, I see, which takes the matcher object, and that's the self-test. No, that doesn't matter. Sorry, I'm confusing you guys. I'm trying to get this right. This is research pattern text. Come on.
Do a rematch.
Match matches the entire string. And so for that, I would need to add, I believe that wouldn't work. But of course I can try. You see, none. Because for that, the pattern would have to start with the caret, the hat, and then dot star, so that it can match the whole string. I want to search within the string instead. And then
Fine.
This matcher.
Wouldn't it be find? Find all?
That is in Java, not in Python. So even though this Python one is implemented using the Java one, still it uses the Python convention. So this is re search. And then, come on, this returns a matcher.
Could it be I mean, in the script you've written re.compile text. Should it be text? Shouldn't it be the pattern, like the reject expression?
Actually, look at it. The text is the file, and the pattern is recompile 72F11. So the pattern itself is correct, is what I'm looking for, the pattern. The text is the file in which I will look for that pattern. It's just that this is giving me a matcher object, and I've forgotten completely how do I deal with the matcher object. And I'm trying to find out how did I do it here. And basically, what I did here is, no, that's finding in there, and this is filter. Woof. I'm not remembering how to do this. This is the filter function. What is the function? Is this partial research? Yeah, it's research. And search returns something that is not null. And so, can we print this matcher? That's what it does. I'm stuck. But okay, when this happens, we can do this. We can do print directory of that object that is being returned. And this tells us what does it have. There's the groups, there's expand, there's this, there's that. Basically, it's not none, which
You
that
have
could
to call
qualify.
process match.
I don't think so.
No?
Goodness, come on, this cannot be so hard. this would be, it's not expand, is, I mean, probably, if we look at the groups, I mean, the point is this returns not null. Like if the text was wrong, basically, if the text was, we add another character here, this returns none. Yeah, so that should be suffice for Python, in which if this returns something that is not none,
I think
it
that
should work.
it should be. I think that it should be path rather than text.
You mean this should be research text pattern rather than pattern text?
Pattern and then path rather than text. Because you.
Oh goodness, yes, you're completely right. Here it is.
Okay.
That's the error.
Yeah.
Oh my God, thank you so much. I had not realized. Yeah, well, good catch. So let's clear this. Let's make a new one. Let's run again. So fortunately, parsing text files is very fast. Now let's take our pattern. Let's put it in there in this tiny text field. We should change the font really. Now it's filtering. And there it is, filtered. Instead of 700 something thousand, we only have 63 entries. And now these 63 entries give us the files that we want. And remember that we had here a click listener, so we can double click in here. The Fiji status bar is saying opening the file, and there's our file. I don't know exactly which image that is. Some interesting image that I'm going to try to show prettier, but it doesn't. Okay, whatever it is. Bottom line, that's it. So this is the very basics of this much bigger plugin here. And so now, instead of going through it, you now have enough understanding to be able to go through this and understand what this is about. The table model for the data of the table, and then I implemented a filter function very directly in the model so that it changes the filtered paths within the model itself. The row click listener is pretty much the same because we copied it. The enter listener is a convenient one, so that instead of having to double click, you can do things with your enter key. And then the open image from table cell is complicated because it wants to deal with files that ImageJ may not necessarily be able to deal with. And then the arrow listener, this is an additional text listener that I'm going to now close this one and open this instead. So let's see. Now this adds the full as I like it to have it, right? So here I can do that filtering again. Oh, of course, here for filtering, I need to put a backslash at the beginning. This is a convention in many text fields that if you start with a backslash, you use regular expression search. And then notice now that my cursor is blinking in the text field. If I push the down arrow in my keyboard, suddenly now I'm in the table. So I don't need to use the mouse for anything. As I list now one of these files, I can push enter, and the file opens. And it opens instantaneously in this case because it's a file I had opened before. So this is yet another convenience to add more listeners, basically. And as I reach the top of the table and I push the up arrow, now the text caret is once again in the regex field. I'm not sure you can see it, so I'm going to shift move to so you can select that there's actually, yes, the text caret is there. So in a way, what we did is with the arrows, we said, let's move from one component, the text field for the search, to the other component, which is the table. This is done here with an arrow listener, which is basically a key adapter. It listens and says, okay, open kpress if the source is the table and the event is the up arrow, right, the event key code. Then if the table is at the 0 index table row, then request focus in window for the regex field. The regex field is that text field where you filter. But if the event instead is the regex field, happens at the regex field and the key was down, then do the opposite. Request the focus for the table, and then get the selection model of the table, clear whatever selection it has, and set the lead selection index, the first selected index of the table, to 0, which means the first row. And so with this very simple trickery here, we make it very easy that we never have to use the mouse. We just move the arrow up and down the table into the text field and back. And so there's more details here, but this is basically how you build a UI, etc., etc. And then at the very bottom, which I built specifically for this workshop, is a bunch of hackery for iterating over all the components here, meaning the label, the text field, the table, this other label, this other text field, and adding to all of them a key listener. So when I do, Control plus, I increase the font size, and when I do Control minus, I decrease the font size. Control Shift minus, actually. This is so that I could show this interface better in a screens that resolution is not as large as the one I'm using. So from that script, you'll be able to learn this. In the chat, this link is in my GitHub repositories, Cardona/scripts, and in there you'll find it in the tabulate filepaths.py. Right. So we've now been ongoing for about 2 hours.
You can see the screen, but not your video feed.
Look, that's okay. I mean, my pretty face you probably don't need to see. I have no idea why. I mean, this is all on. So, all right. Next one. So next step. Now we've basically created a solution, a rather makeshift quick solution dynamically, right, for being able to go through your large collection of files and being able to quickly find them and open them. And with that, we've demonstrated basically how to easily create an interface, a graphical interface, add hooks into it, these listeners that enable you to, like, say, double click on this or push enter on it to open a file or to print or do whatever you want, right? And also you realize that the components in there can be moved around, can be relayed out differently and so on, even dynamically, even taken from one window to another. So there's a lot of flexibility once you understand how this works. But coming back to the biological application, or rather biological research application, is managing large collections of files. So the next app will be, now, how do you keep track of all of this enormous amount of files? And so now I'm going to go and open another file, which I need to remember where it is. This is going to be called what? See, I can use the notes here. I'm pretty sure it's called notes. Yeah. File open history with notes. Exactly. That's what I wanted. So instead of recreating this one, I'm just going to slowly walk you through it. But maybe the first thing I'm going to do is simply run it. So what does this do? Here I've created another user interface. I'm going to make the font a bit bigger so that things become clearer. And you all guys can hear me, right? Because everybody's very quiet.
Yes.
Yes. Good. Thank you.
And we see you as well.
So, yeah. So now look what I'm going to do. I'm going to minimize the script editor. And let's get rid of this window. Now, what I want to have is, okay, I don't even need this terminal. I don't want any distractions. I want you guys to focus on what I'm trying to show. God, how many terminals do I have here? Okay, so what's happening now is I have here filtered for 722 F11. So I have a bunch of files, right? So now I'm going to open one of these files, say this one. And now look what happened in this other table. Suddenly, here, when I click on it, I see this is the file path that was opened. It was first opened now, and I can try to make the window bigger. So this becomes more obvious. No, okay, I will need to resize this somehow. I guess I can resize it here. So this shows me the time where it was first opened and the time when it was last opened. Of course, the first time you open it, these two are the same. But say, suppose I had opened this file as well yesterday, it would find this entry here, and it would simply update the last opened, and it would show me the file path where it is. And if I click on it, it brings it to the front if it's open, or if it's closed, when I click on this file path, it opens it again. So what this will do now, if I go and open, say, the next file, let's open this one. So there it is, 2 files, and in principle here, there should be another row. Did this file not finish opening? What exactly happened now? Sorry. There's something that went wrong with this file, and I have no idea why. Okay, here it is. Okay, what I'm seeing is that somehow it's not adding the files. Why is this failing now? This should be adding 1 row per every file that I open. And this was working before, and now it doesn't want to work. Brilliant. How is this not working? Goodness. I'm running out of energy to debug this right now live for all of you. But basically, I will look at this later and try to find out what happened in my local copy here. Why can it not work when it should? The point is, you have here now, again, a regular expression search where you could filter all the files that you've opened, say, today or tomorrow or yesterday. And then, where is this table saved? For that, we need to go back to the script editor, which is right here. And basically, where it says edit here, CSV image notes, there's going to be a file that automatically it's created at your system property user home, meaning your home directory. It creates a hidden file for which it adds notes. You could change this to make it open a new file for each data repository that you have. It doesn't matter. Or you could simply have one, for all the files of your lab. It doesn't matter at all. The bottom line is you end up with a persistent collection of events of which files have you opened. And then for every file, you can go and edit a note and say, this is the file that I was showing to my, lab mate. This is for, Gal4 line 72F11, etc. And then save the note, and the note has been saved. So now if I close this, in principle, when I open it again, and now it has the files that I opened that somehow didn't update. When I click here, this is the note that I had just done. I'm going to make the font again bigger. So I see now the nature of the bug is that it's not refreshing the table properly. So this means I know exactly where to go to fix it. Let me see. There must be somewhere an image listener for the table, filter table, type in search, open that folder, click edit button. Where is the image listener? Add or update entry. It has a table repaint. All the image listener does is call our update entry. Somehow this repaint here didn't work well. And I don't know why. But okay, bottom line, the example is, if you're browsing a collection of 737,000 files like I have in here, and this is real, this is a data set acquired over several years by Jim Truman at Janilia, and also by Marta Slatic and myself, on larva, Drosophila larva, Gal4 line images. Basically, you will end up with a large collection of notes. This note will be what? In an Excel spreadsheet, in a text file that you have, in your lab book, in emails, in whatnot. This file has this file has that. I find that crazy. And so instead, what I want is to be able to first browse my image collection or my various image collections easily. Second, for every image collection, I want to have a CSV file that keeps track of when did I look at it, when did I last look at it, what notes did I take for that. And these notes are persisted to disk into a simple CSV file. So if you ever need to open that in Excel to do something else, you can. The CSV files are the simplest, spreadsheets you could possibly think of. And then the convenience of these is that it gives you options to like double click into the file path and it opens the image again. Unfortunately, it doesn't remember, which you could if you wanted, in which section were you imaging and what brightness and contrast parameters you were using, which that would be handy. That is left as an exercise for the user. Bottom line, that the same way you persist to a CSV file these timestamps and your notes, you could also persist additional properties of the image, such as the brightness and contrast, min and max, display settings, and so on. And then something else convenient is, here is this button called Open Folder. What this does is, for that image, it pulls the Open File menu, so to look at basically sibling images in the same folder, which is something we often do. Because these are folders nested over nested over nested, many, many folders. That particular folder contains multiple files that I'm interested in. Say, if I start typing here 72F11, I start to see these are all the 72F11s that I want to look at, right? So that's yet another way of opening files, not just this file, but files in the same folder. And then what you see here at the bottom is simply that the nodes, because you're scrolling through the table, you're erasing these nodes in a way from this screen. There is a specific method where you click an edit node to make the node editable. And when you are done, you say save. If you don't, it will ask you to save when you change to a different row. You can always say, no, don't save, and then it will discard it. And it will keep the node as it was before. This seems like a very simple thing, but actually it removes headaches to a point that you wouldn't believe, because suddenly you have everything in a structured way, in a, say, one single CSV file for each one of your data sets. Because remember, in the script, at the very beginning, you can either ask it to open a file, like we did for the tabulate file paths, or here directly, simply you type which file path you want. For this data set, for that data set, etc. You can even have them commented out, and then you comment, and then you comment in the one data set that you want to use at the moment when you run this script. Okay, so with that said, there is nothing new here that you haven't seen before, except something about threads. And that's maybe interesting enough to give it a couple of minutes. Before I mention how to create a new thread and run something on it so that we're not giving expensive tasks to the event dispatch thread, here you will find that we're using the executors and the time unit. So Java is excellent at running multi-threaded programs. It makes it very easy. So I'm going to look here for something called exe, which is oops, not that one. Let's look for it again. Here it is. So basically, how do we save this file to disk? And you could save the file by whenever you push the save button, remember in that UI? Where is it? Here. Let's put it up here. Whenever you push save note, you could write it down immediately. There are good reasons why you don't want to do that, which is you don't want to put an expensive operation in the event dispatch thread. But then you can start a new thread for saving this file. Sure. But then if you go and edit the next node and push save again, there's going to be two threads that are saving onto the same file if it took that long to write. Okay? So what you want is to, instead of saving the file, you want to request for the file to be saved. And then there is a background thread, which is a scheduled thread. And this is what this makes it very easy. What we're looking at here is executors, new single thread scheduled executor. What this does is it creates a system by which you can now say schedule at fixed rate. And now there's a single thread that every 500 milliseconds wakes up and runs this function, save table. And what does save table do? Well, save table is here. And all this table will do is it will basically check while this is not true. You see that it says request save CSV? This is an atomic Boolean, which is defined up here. What's an atomic Boolean? It's a variable that you can only update one thread at a time. The other threads that want to update this variable have to wait until this variable has been read or whatever it is that the other threads are doing to it. And so what I do here is in a while loop, I say, tell me whether it's true and set it to false all at once, get and set. If it returns false, this doesn't run. If it returns true, this runs, having set it to false, by the way, so that it will not run again unless this request has happened elsewhere. And so when that happens, then it says write to CSV and then invoke later this after. And this after is basically an update of the user interface elements that is running the event dispatch thread, which is basically, change the text of the node to saved. Remember that if we push the button here to edit the node, this changed to editing. It's like a status bar if you want. And then when I push save node, and also this button is disabled. So when I push save node now, this button is enabled again, and this just changed to saved, the status bar. This is done here. Edit node, set enable true, save node, set enable false, and node status, set text saved. So this looks like overly complicated in a way. It's actually rather straightforward once you understand that this makes everything trivial. And the one conflict point between multiple threads trying to do something is managed by the atomic Boolean, requested save CSV. If we look for this variable, you will see that it's also used in the function that deals with the add or update entry. So whenever a new image is opened, remember there's an image listener here that on image opened adds or updates entry. Adds or updates entry does all kinds of things for updating the table, but also requests that the whole CSV file is saved to disk. And then in addition, this is also done in the request save. And this request save is run by the button. When you push save node, it doesn't save the node. All it says is it updates. It says this, signal to synchronize to disk next time the scheduled thread wakes up. And so that way you can coordinate from multiple UI buttons that all of them are kind of triggering events, that the file is saved only one at a time, by one thread at a time. So if you understand this threading model, you have an incredible tool at your hands to do all kinds of UI things without having any kind of conflict when it comes to, say, dealing with files or dealing with expensive data sets. Right, so now I'm going to stop here with this one. And I want to go onto a very different data exploration mode, which is one of the other scripts that I've given you. For this, I'm going to stop this share. And is my video still not showing somehow?
No, it is showing.
No, it's showing.
Now it is, good.
Yeah.
So see, Zoom just had a snafu somehow. I mean, these things don't make sense, right? All right, so now the one I wanted to show you is less on UI and more on heavy-duty stuff. So let's see if I can find it. Right. So what does this script do? So now picture this. Suppose you're using a focused ion beam scanning electron microscope, and it acquires images which are giganormous, of like, say, 10,000 or 15,000 pixels on the side. And you have several hundred of these pictures. So these pictures, as you acquire them, and they are big, they are huge, you want to keep track of them, you want to look at them. It's difficult to even load them. It takes time. And then the microscope can be configured so that it saves the images raw, which you always should prefer it in most of these microscopes, because if you try to compress with TIFF or whatnot, the compression, the high frequencies of the image in electron microscopy, for instance, is so high that the compression is basically null. It just adds overheads. And if you have it raw, then you have the ability to load chunks of the image really fast, because the bytes on disk are the same as bytes on the image in the screen. and it's a one-to-one mapping. So then what can you do with that? Well, something you can do is you can load only parts of the image. You don't need to load the whole image. So it is a script, and I'm going to run it now to show you what I mean. So here, I mean, this is only a small image, but it's a little stack that will serve as a test, okay? And so this little stack, suppose this was a giga-enormous image, it would take too long to load if you want to browse through z-axis, say, effectively. And so instead, what I did in here is this so-called sections crop. This is the title of this window. And what you're looking at is only a fraction of the data. Do you see that this image here is basically the same as here? What you see on the left is what you see on the right. The magnification is slightly different because this one is not at 100%. Now it is. Let's put both at 75. Yeah. Right, so now what I wanted, this has only loaded that little bit of the image and not the rest. And then what you can do is using control and the arrow keys, you can load dynamically the rest of the image. And as you read the edge of the image, it starts being black. Because essentially what you have in here is an infinite canvas that happens to, in the interval where the original image is defined, it paints the pixels of the image. But outside of that interval, it paints black. And so think of it as some kind of region of interest that you move over your image. But actually, what you have in here is an ImageJ stack. So if this is an ImageJ stack, you can run plugins on it, you can run machine learning on it, you can do all kinds of things on it. But as you do that, it is non-persistent. So if I go here now and I say, integral image filters, normalize local contrast, and I say preview, let's make a window of like 100. Maybe not stretch, I don't know. And maybe this image is already too contrasted to run this effectively. I'm not sure what would be a good example. Probably the Weka. Some kind of automatic segmentation in here, for instance. That's something you can build from a script. And maybe we'll try to do that now in a moment, if I can find the right words. So how does this work? How can you take a list of images from disk and create a virtualized view that actually happens to be also an ImageJ virtual stack so that you can fully interact with everything else that is in ImageJ? Well, let's look at the script. You need a folder where you have a bunch of images, in this case, raw images. They don't have to be raw, but it's easier for this example. Then, given that they're raw images, there's no headers in the files of the images, so you need to know the dimensions, and you need to know the pixel depths. And then load the file paths, which is, again, a list comprehension that joins the folder path with the file name for all the file names in the sorted list of file names of that folder. So OS, list dir, folder path. This is standard Python stuff. And then desired dimensions for reading in chunks. I mean, this is tiny because the example I'm using is very small. But if you have a 32,000 by 32,000 image that may be even too big, even for Fiji to show, because Java has this 2 GB limit on the length of the arrays for some reason, you can put in here, 5,000 by 5,000, 10,000 by 10,000, whatever it is you want to load as just a chunk. And that would be your cell width. What does this cell mean? It means we're going to use an image lib2 image that is actually a cell image. And we're going to start see how we define this cell. Essentially, instead of having, you can think of this image as having one single cell that you load all at once. But imagine if instead of doing that, we were to do it in little chunks. You did this chunk, and then you do this chunk, and then you do this chunk, right? And the cells are like a grid on top of the image. And so this, okay, we say cell dimensions are the cell width and height. And then the volume dimensions are the width and height of the entire section and the number of file paths. These are our 3D dimensions. And then with that, we're able to define a cell grid. So I don't know if you can see the font properly in the screen, but the cell grid here just needs the dimensions of the volume and the dimensions of the cell. And this is a construct that says, okay, now I know how to partition the the whole volume into little cells. And these cells have the width and height is 256 to 56, and the depth is just 1 from one single section. You could make the depth whatever you wanted, but in this case, it's convenient to do it just 1 because it maps to the two-dimensional images on disk. And then how do we, let's ignore this for now. And I'm going to go down here. And now comes the secret sauce of all this, which is you need a cache loader. And a cache loader is an interface that has a single method called get. Get at index. What index? This is the index of the cell. And then how do we know which file to load is the question, right? And then we say, okay, so we're going to take, and we need an array of the minimum coordinates of the cell. So this will be the X, Y, Z, where the cell starts to be defined in the 3D space, and the dimensions of the cell, which may vary. For instance, if the grid reaches the edge of the image volume, those grid cells will be a bit smaller than the grid cells in the rest of the volume. And then there is this method that gives the grid that populates the cell min and cell dim. So this is a bit indirect, but essentially these are empty arrays, and now we populate them. For that index of a cell that we're given in the get, tell me the cell min and the cell dimensions. Fine. Once I have that, I have the X, Y, and Z from the cell min. If I have the Z is shared for all the cells of the same image plane of this volume. And the Z I can use to get the file path at that Z. Correct? And then from the dimensions, I don't care about the Z, which is 1. So I put an underscore, which is a convention for variables that you don't care about. And then width and height you get from here. So now I have everything. I have the Z to get the file path. I have the X, Y, where to start reading the file. And I have the width and height, how much to read starting at that X and Y. And so now what I do is I define a random access file for read only. And I have and then this image, of course, is one enormous single array written in disk of bytes. So now what you want is to create another array with this zeros function. These zeros, by the way, I'm going to go to the top. It's from the package array. You create zeros, which is a native Java array of whatever type you want to define. And so in this case, the type is B, meaning bytes. And then the read width is how much do you read every time that you want to read, which is in this case the width of the image. Here's the read width, the width of the image times how many bytes per pixel. If it's an 8-bit image, it's only 1 byte per pixel. If it's a 16-bit image, it's going to be 2 bytes per pixel. So that's basically your band. In like TIFF formats, it's called a band. So I create an array enough to read basically the entire image because it's the band and then how many bands do we have, right? Are you following? Nobody's complaining? And so, okay, with that now, I can compute the offset from the beginning of the file. Remember, it's a raw file, so the very first byte of the file is the very first byte of the very first pixel. So the section width is how much I have to skip, right? The width of the whole image times how many rows, right? Plus the x, so the x coordinate that I need to go, plus the bytes per pixel. So times, sorry, the bytes per pixel. This is all the bytes in the file that I don't care about. And then if the width happens to be the section width, it's easy. And we can just read the whole thing as a block. Basically, this is where you have a cell that is as wide as the whole image, which is not the case here. So else, you have to read one line by line. And so you have a little loop that says, as long as you've read it less than the total number of pixels that you expect, the number of pixels you expect is the width times height, we're going to jump the pointer of the file reader to the offset, and then we're going to read into the bytes from how many bytes we've already read, which is 0 at the very beginning, that many bytes, which is the width of the band, right? Which is the width of the little cell that we're reading times the bytes per pixel of that cell. And then, okay, then good. This now we say the number of bytes read is basically the read width, and the offset now has moved, which is the whole section width times bytes per pixel. So we have to go now to the next band. Basically, if I come here and I draw this, if we were to read this cell, it means you first offset all the way, all of this you need to offset all of these plus all of this needs to be offset. Let me choose a different color, like say red. Of course, that's a gray image. All of that needs to be skipped, and I need to reach the beginning of this white rectangle. And then I need to read one line of this white rectangle, and then skip the whole width again, which is the distance from this point to the next point here for the next line, and the next line, the next line. And so I will read this white line one by one. And so as I do that, I get all the data that I need, and now I can return from this method, remember, from the cell loader, I can return a cell. And this cell is an object that consists of the dimension of the cell, the XYZ position of the cell, which is the cell min, and then an access object. What is this? Well, this contains the bytes and the bytes per pixel so that it can create, where is it? The correct kind of volatile byte array or volatile short array or whatever. And so this is, again, one of these ImageLib internal data structures that wraps the actual arrays of pixels. And so with that, I can do this enormous monster thing, which is first I create a cache. And so that every time, why do I need a cache? It's because if I want to go back, I don't want to read it from disk again. What I want instead, let's go here, is to read it as fast as possible. And so the cache enables me now to jump to the next image very fast. But as I reach an image that I haven't read yet, it'll take a moment to load because it has to read it from disk. And as I pan the view with control and the arrows, you see that it gets stuck sometimes. That's because it's waiting to load. But once it's loaded, now it can browse completely freely and continuously. And so yes, you want a cache. And this cache is done with soft references. And the soft references is a construct that enables you to have automatic average collection. So if you load too many pieces of your pretty much infinite image, it will throw away those that are not in use, that have not been used recently. And so it's automatic memory management done in a very good way. And so this soft reference cache, all it needs is us to give it our cell loader. And this unchecked and whatnot, these are various ways to construct this for most efficient performance. Then with that cache at hand, now we can create an actual image for ImageLib, which is basically this horrible, very long name. But if I was to explain this gently, this is a factory that creates a cell image from a cache loader by giving the dimensions, the type of the image, the cache itself, and then various options. In particular, these options is basically you want volatile accesses and the dimensions are such and such. This volatile access, volatile in general means these are resources that may disappear any one time and you need to be able to reload them if you need to. So that's a very complicated way of saying is express that volume in a bunch of little cells that can be loaded from disk that now I can wrap using the ImageA functions that I always abbreviate as IL into an image into an ImageLib image that I can show. And once I show that image, that's what I get. And so I get that, and that has no hooks in order to move it. So how can I navigate that data set? Because remember, this is a little window onto an otherwise enormous data set, right? So the data set is here. Sorry, the way to control this is here. Now show a user interface that enables moving a window around a data set, right? This was the whole data, by the way. If you ever run this, be careful because this is the entire thing. So if I run it again, this is the first one, basically. where it's the entire quote, quote, gigantic data set. Here is just a very small one. Also loaded as a cell image, plain. This one here only looks at a tiny bit. So in a way, this is loading all the cells, and the other one is loading only the ones that it needs within the region of interest, which is, because this is an ImageLib image, we can slice it in any way we want. So we can look at a subset of it. So that's what this does. And the key to this is views. This views object is extremely useful to be able to acquire, basically, if you have a 4D data set, you can acquire a 3D data set, or even a small chunk of a 4D data set or whatever. In this case, you have a 3D data set. I want to see a smaller version of it, or a small subset. And so now what I do is I define a minimum and maximum coordinates that I want to see from that big data set. And then with that, I also then wrap my image by giving it an infinite canvas. So what this means, remember, is that if I scroll to the end of the image, now it's black. Why is it black? Because I said views extend 0. I could have put a gray value, I could have put mirror, I could have put anything. There are various options for extending an image. And then this is essentially an infinite image. That's not very useful because I cannot visualize an infinite image. So now I crop it. And how I crop it? By requesting an interval from this infinite image. And this interval is no other than exactly the minimum and the min-max coordinates that I've chosen. With that done, I can wrap it so that I can get an image plus out of it. This here is an image plus. I can annotate it like this. And then I can just call show on it. But of course, if I have an image plus with this frame and so on, I can now go back to what we were talking about before, which is listeners. And so once shown, I can get a reference to the window. And from the window, I can get the canvas and the key listeners that it has. And here I store all the key listeners. And I get rid of them. I don't want them. I want to replace the key listeners with my own key listeners. And the reason I want to do that is because later I want to replace the control plus and minus. I mean, keep in mind that if I go to this image and I push control arrow, it moves, for instance, in this direction. It doesn't pan the view. It's moving now in Z, in the Z axis. Whereas I want to remap the control arrows to pan the view. How am I going to do that? Well, first I need a trick, which is I need to get the stack. And this stack is one of these ImageJ virtual stack and sign byte, whatever. The point is that one of these classes has a declared field, which is the source. And I want to make that field accessible because I'm going to edit it. I'm going to change it. Again, we're hacking. But I mean, if the API is there, it's there for you to hack if you want to. And so now, how do we navigate the data set? And by navigate, I really mean we're going to change the interval. Remember the interval here that I use for cropping? I'm going to use an interval that has the same dimensions, but different coordinates. And so the way to do it is I get the key, and if control is down, and the key code is in the navigator moves, and this navigator moves is a variable here that is basically this dictionary. This dictionary of up, down, left, right, I move by 1 pixel or minus 1 pixel in this direction or this other direction. Actually, these are the dimensions. This is the y-axis, and this is the x-axis, and this is -1 means to the left, 1 means to the right. This means up, this means down. So then it's all about finding out. If you push shift, it moves by 200, I think. It's a bit faster. Let me see if it's true. Yeah, now I move by 200 pixels at a time. If I only push control arrow, I move by 20 pixels at a time, which is this little logic here. And then again, I just get the everything right, and then I set a new source to that virtual stack. And this new source is no other than my infinite image, remember, extended 0, with a new interval that has the same dimensions but different origin of coordinates. And then because ImageJ has 0 base coordinates, I need to call view 0 min, which is essentially a view of that interval where all the coordinates have been subtracted so that the top left is 0, 0. And so this view 0 min, views interval, is exactly what we need to now show it a different source. And then I need to tell ImageJ to update the data. And the way to do it is to say update virtual slice, meaning, look, the data has changed. You need to update whatever you're using to render the pixels into the screen. And then if that's not the case, meaning control is not down and the key code is not one of the key codes that we care, then, you know, pass it on. Let this event pass on to the other listeners so that all the other key bindings from ImageJ continue to work. I've only hijacked these 4 key bindings, the up and down, left and right. Because the up and down zoom the image and zoom it out. I don't want to do that. I want the up and down instead to pan my view so that I can navigate my data set. This is a very small script. Of course, don't forget to add the key listener, right? This really has like 100-something lines. But basically, with this script, you can take literally 200 terabyte data set and navigate small bits of it reasonably fast. And in these small bits, you can run anything you want. And so here, if you now had some machine learning, you could say, okay, let's look at how the data acquisition is going. Is this data segmentable? Is it good enough, right? How would you do that? I think that's the last thing I want to do today, if the 18 remaining people are still with me. Can I hear some ayes or something?
We are here.
Aye.
Yeah,
Good. All right.
Yep.
I'm here again.
So soldering on. Good. So now we have this view, right? This view of our gigantic data set. Now what I'm going to do is I'm going to go and use some very trivial and simple machine learning. But keep in mind, you could use any machine learning you want that is available in Fiji. It doesn't have to be the one I'm going to show you, okay? So where is that? I'm pretty sure this is under Weka. No? Oh, come on. Is this case sensitive? No. Goodness, I forgot where the script is. I need a moment, please. This is, I'm pretty sure it's here. How have I lost this script? Okay, I'm going to have to search it. It's test synthetic EM. I see. So I'm afraid it's somewhere down there. Wow. Where is the synthetic EM? There it is. Basically, since I don't have any training data, I'm gonna make it up. Let's see what I have here. Is this a standalone script? Can this run by itself? I think it may. It's importing a bunch of things, makeups, blah, blah, blah. Yeah, but where is the actual image? Aha, it wants this image. Okay, let me see if I can open this recent image. Is it this one? It looks like it. All right, so for this image, what I'm going to do now is run a script to check that everything works. It didn't. Cannot import name block. What? Oh, no. I see. Okay. Sorry, I'm going to need a minute of preparation. This will be, where is this? In my workspace, ImageLib2 algorithm. Yeah, the block read was never. Oh, goodness. I think I didn't release it. A simple way to read this. It should have been released. So that's a Maven compilation of ImageLib algorithm repository where it has a couple of functions that I'm missing, essentially. This should have been released to ImageA, to the Fiji updater, but it hasn't. It will. I'm going to move this to my Fiji jars. And then I need to go to my Fiji jars and remove the old file. It's very, I mean, this should be done better than this, but at the moment I cannot be bothered to do it any faster. This I need to move somewhere else. Okay, out of here. This means I need to restart Fiji, unfortunately, but that's right. Come back again. Please. Goodness, that's taking a very long time. Okay, Fiji, new script. And let's open recent. We had this one, which we want to run. And we had that one. Sorry, family coordination. Let's see. You're still seeing my screen, aren't you? Very good. Right, we wanted to work on this, and then we also wanted to open that sample image, sorry, that recent image, which was this one, and hopefully that script now can run. So I will explain what a script does in a moment. It's still running. Wow, it's taking its time. I guess the very first time, the wiki takes a long time. Will it show me, please, the images? Still running. Now it's probably classifying the image. Come on, that takes too long. Ha, there it is. Okay, so what have I done here is I run a script that is called test synthetic EM. You can find this script again in my github.com/acardona/scripts. And all it did is it completely made up training data by creating this synthetic image that imitates how electron microscopy images of neurons look like. So it created these bands, which are actually like cytoplasmic membranes, and then there's a bit of noise, which is shot noise, as well as some physical looking noise. And then it has different shapes, and some of these shapes are a bit more blurry than others. And then with that, it classified a multi-layer perceptron that enabled it to do a classification that is actually not terrible, surprisingly, considering that this is garbage in, garbage out, right? So now, in the same way that we've run this, we can run this on our data, because what does it matter? This is just the image, right? So this is the image of our gigantic 10 terabyte data set that we're just browsing, piecewise by having it expressed as a cell image for ImageLib, right? So let's see, how can we run this now on here? Let's see. I need to remember how this works. And of course, some are much faster than others. For instance, the multi-layer perceptron is actually quite slow. What we really want is the SMO. This is like support vector machine. It's extremely fast. We should use that one now. And we should not use the multi-layer perceptron, which is way too slow. So let me see. I'm just commenting our entire blocks of code. And then here, what I want is to free up the SMO. Okay, so in principle, this now should work with the SMO, which is still running. Oh, come on, this used to be very fast. I think my computer is overloaded somehow, but otherwise it is much faster. The result is very similar. Notice it's different in various ways. Somehow the multi-layer perceptron did something better at some places, but it doesn't matter. This is just for an example. Is, okay, so how do I apply this to here? I need to get this section scrub image, right? And you could save the classifier, which this is not saving it. I mean, there's all kinds of tricks we could use to make this a lot faster. I'm not saving the classifier, I'm training it every time. Again, there's a lot of overheads. I'm not doing this correctly. It's just as an example of, can you do non-destructive stuff that is actually interesting? So for this, we would need an image. In this case, I think what I want is just the current image. So instead of this one, I would like that one. So I'm going to call this imp.em equals that. And then this image is a stack. So I don't want the whole stack. I want just the 2D image of it. So I'm going to call get processor on this, because this is returning me an image plus. And then for this image plus, I'm going to create a new one, image plus with title. This would be basically a subset or ROI or something. ROI of large data set. I just want to get that processor. And with that processor, then we can do everything we need to do. So let's see if that works. If that works, this would give it a segmentation of these. So again, it's classifying with a fast random forest. Oh, that's why it takes so long. The fast random forest is not commented out. Yeah, goodness, no. I don't want that. The SMO is very fast. Next time around, a little faster. Oh, I see. When it gets image, it gets the training image. Never mind. I need to rerun this. So instead of get image, I need to use the same trick as before. I'm going to use this. Here. This image is called by title, sections crop. And all right, that hopefully will do it. Because that is the title that this thing has. Yep, good. Still running. Come on. That's taking a bit too long. Boo, come on, my poor laptop. I should have done this in the big server. There it is. All right. Again, the training should be done separately. We should load this stuff. But bottom line, that's one way in which we can get a segmentation for this. And actually, segmentation is pretty good. I mean, I'm kind of shocked at the unreasonable power of machine learning. I mean, I made up the training data. Can you believe this? It's all in this script. Sometimes this is a bit inspired by the content-aware image restoration. The training data sometimes just needs to be what you think it should be, as long as the underlying structures are correct. It captures so much of your image that even the microtubuli are there. Some in here, some in there, but the membranes are there, which is what I wanted. It's really something. You could do actual science with this trivial segmentation I just made. So how does this script works? Basically, the generation of the fake training data, it's all using the ImageJ's libraries for take a float processor, in the float processor set color, fill it up. I'm sure you can see this font, and then define a bunch of neuroids, which are these oval rows. And then for every row, you want to draw it with this particular line width and color that you set for the float processor. And then the oblique membranes, the color is different, meaning so it's fainter, and the line width is thicker. And the oblique membrane is actually this one here, which is a bit towards the bottom right of the training data. If I make it bigger, you'll see. The color is fainter and it's thicker. That kind of imitates slanted membranes in electron microscopy. And so then add some noise. We add vesicles, which is a bunch of oval rows, randomly at XY positions. We just draw oval rows and then Gaussian blur the image and add some shot noise. All of that is standard from pretty much the float processors in ImageJ. Again, the example is in GitHub. You can see it easily. Then we show that image, and then the training. How does the training work? I take basically all the ovals that we had used to draw, and for those ovals, I extract the polygons. So all the ROIs give me the polygons. The polygons are basically the sequence of XY points that describe those ROIs. And then there's some for membrane, there's some for membrane obliques, some from, that's the length. And then the background samples, I take a rectangle, and the rectangle will give me only 4 coordinates, which is not enough. So I say, okay, give me an interpolated polygon every 1 pixel, so that instead of 4 points for that, the polygon of the rectangle would have hundreds of points, all along the lines of the rectangle ROI, of the borders of the rectangle. And then I don't want that many. I only want as many as, because there are 433, I only want as many as I have len membrane, so I crop these lists, up to len membrane, not more. So now I have the same number of training samples as I have for both kinds of labels, for membrane and for non-membrane. And then with that, I go on and import a bunch of SMO classifier convenient functions and so on from a library that I created that is also in this GitHub repository. And this library simply uses the Weka. And this is very straightforward. You don't even need a library. It's just that I couldn't be bothered to write this every time, how to create the SMO classifiers. And then you need to be able to get samples from it. So this is a generator that just creates for XY a particular class index over the ROIs. I'm going a bit fast, but I think we should finish soon. And then some methods for making, for reading basically a filter banks at every coordinate of these ROIs. Say, suppose you have an ROI like this, and you have 50 or 100 points all along this ROI. What you want is to be able to extract. Whoa, that's not what I meant. Sorry, I want to pan the view here. What I wanted to do is extract the properties around any 1 pixel. So for that, one creates a filter bank of block statistics with rotations. I tried a number of, as you can see, all this commented out stuff is all what I tried out. And then this filter rank in the end is nothing more than a fast way of reading pixels around any one coordinate in the image. And so if you have a pixel here, you want to read this block very fast, and it's done using integral images and so on for various properties. And that's it. You get a vector of readings for every pixel, and you put all of that, all of those samples, which have remember that samples have a class index, so meaning membrane or non-membrane in this case, or even membrane oblique. And that's it. The support classifier creates a classifier, and then the classifier, you can use it then to classify the entire image. It's really not difficult at all. You can follow this example and the corresponding library in the GitHub repository. This is just to give you an idea. So basically, in my workflow, what I have is this ability to represent images that are essentially collections of either 2D or 3D images that exist in the file system as a virtual image using the cell image construct with a cache, and then just visualize a fraction of it so that I can navigate through it in a very easy way without ever having to load the whole data set, which would be essentially impossible. And then for some of these, go and create, say, segmentations or brightness and contrast or fast Fourier transforms to check for the focus of the image and so on, to check whether the microscope needs adjusting. And that's it, really. This is, I think we can conclude here most of the tutorial regarding how to deal with very large data sets, how to navigate these large data sets in an abstracted way that enables random access into it. Because most people don't know about it. Like one more hacking example, if you don't want to go home and you're not done yet, I'm willing to do this. I'll show you a 3-minute example of how to basically deal with bad software that doesn't give you a handle onto the data and the data structures.
Yes, please.
So here, for example, we have these images open, right? But I didn't do the persistent checkbox, so I don't have a handle onto them. Well, that's fine. We can go here and say, okay, or we can do it even from the comfort of a script, where then I have like expansion. So we're going to do here for frame in frames, and frames would have to be, okay, here. Wow, there's a lot of frames. This one, Java out frame. For frame in frame, get frames, which is, yeah, it exists. Right, now we do, print frame. What will run from this? Well, you'll be surprised. Here they are. You now have a handle onto all the frames. So which one of these is ours is probably the last one, even though it has the same title, right? So now I'm going to do here, if frame get title equals this. This is my frame. So I'm going to say here, okay, window equals this. I can just, actually, Python is so convenient that it even defines variables outside the scope of the loop. So we can just do this, right? Okay, we found it. So now we can clear this, make it persistent. Goodness, the console really doesn't like something about this. Run. Okay, this run. So now, who is the window? Window is not defined. What? Well, now I'm confused. Okay, window equals nothing. How about that? Window is none. Okay, that is now confusing me. How is this not the title? All right. I think I'm just too tired. Is it name? Is it what? Is it not get title? Yes, it's get title. Okay, so
I think the D is missing.
Yeah, maybe the virtual is part of the title.
You are totally right, because it is part of the title of the frame, not of the image. Yeah. Good. Now, there it is. There's our window. So if this is our window, now what is in this window? Well, we can do, for component in window, get components. We can say print, the type, the class essentially of the component. So again, Shift Control R. There's an image canvas. There's a single component in there, and this image canvas somehow can do a lot. That's fine. It's kind of surprising because there is a tag in there. How is that even painted? It must be part of the window itself. Well, there it is. So if I have an image canvas, so now I can do if is instance, comp image canvas, which is that one. My canvas is basically the component, right? Right, so if I have a canvas now, I can get an image. I'm pretty sure that's the case. And now I can do this. No attribute get image plus. Is that right? Can this get the window? No attribute get window. Okay, what does this have? I can do here print there canvas. It must have something. There's tons of things. But actually, more conveniently, we should look at this in here. That one. This has a get window here, which returns an image window. And the image window itself has a get canvas. It's the image window that has that. But the canvas itself doesn't have a get image. Yeah, it's called get image instead. There you go. Okay. So basically, my image is that. Yep, there's our image. You see? So basically, if you have a plugin that creates an image, and it doesn't give you a handle onto the image, you can just grab it. This was more than 3 minutes because I made a number of mistakes. But basically, that's my point, right? It's all there. Yeah. There's no way you can miss it. And so no matter what. And you can extend the toolbar. You can do this. You can do that. You can build interfaces rather easily. And so with the many examples in the tutorial that you have in that webpage, you'll become master of like JTables. And the JTable is extremely powerful. Good Lord. I mean, you can edit cells, add nodes. I use it for all kinds of things. It's just